Hello everyone, this is Reza. Welcome to another video of FX series. In this video, we're going to talk about Bifröst Liquid in Maya. Now, Bifröst Liquid is used to create all types of fluid effects, including open water, fast-moving water, turbulent liquids, as well as semi-solids, such as lava, mud, or gels. Now, I've put together a very simple scene. I've modeled these two guys with Revolve tool in Maya, textured them really quickly, and I'm ready to go. I didn't create any liquid, obviously, because I would like to create the liquid using Bifröst simulation. What I did though, I created the emitter for the liquid. So if I isolate the object, that's what I have. A simple cylinder, nothing too special. I'm going to use this cylinder as an emitter to create my Bifröst fluid. So I'm just going to get rid of wireframe on shaded, go to wireframe, and let's talk about a few things before we start. And go to animation. I set my evaluation mode to parallel, but this cache playback is off simply because cache playback is not supported by Bifröst. So you can leave it on, but it won't have any effect on your simulation. Next, if I go to time slider, you can see that I have my playback set to play every frame. I'm going to go and set it to 25 frames per second, but just so you know, you can work with 25 frames per second. As soon as you start caching, you have to switch this to play every frame, and when you export your liquid, then you can switch back to whatever frame rate you have in mind and continue working. So I'm gonna, with that 25 frames per second, I'm gonna go save, and let's get started. First step is to define start frame and end frame. I have frame 1 to frame 200. I think that's a good time frame for me. Now I'm going to select my emitter. I need to make sure that I have Bifröst plugins all loaded. So I get this Bifröst menu in FX and Bifröst fluid. And with that emitter selected, I'm just going to go and select liquid. You may think you need to start from the emitter here, but you actually need to start with liquid. The other option is aero, and we've already have an in-depth tutorial on how to create aero using Bifröst graph editor. Now, as soon as you create your liquid, it creates a bunch of nodes in the outliner. They're actually quite important, and you need to know how they work. In order to understand those, with the emitter selected, I'm just going to go to Windows and get my node editor. So let's have a quick look at these nodes and see what they're doing. Well, I have my emitter, and I've already specified my emitter. I have Bifröst Liquid Properties container, and that is probably the heart of the Bifröst, where you specify the voxel size, you fine-tune the graphity, all the main properties can be found on this node, and it actually controls reading and writing cache files. So that one is pretty important. Bifröst Guide Property container, we're not going to talk about that. It's for a different method of creating Bifröst, and it's not applicable in this scenario. We have Bifröst Liquid container, and this node simply gets all the data and values from its input and performs the simulation. It has got some attributes to control how and when simulation is happening, such as start frame and scratch caching. Then we have the liquid shape, and that is the representation of the final result. It has attributes for activating and controlling the result when it's meshed. And of course we have Bifröst Liquid Mesh, and that basically represents the final look and how it's being rendered. It converts the voxel information into a geometry. All right, with that out of the way, let's select our container, select our collider, because at the end of the day, I want this to collide with my bottle, and I can go to Bifröst Liquid and go collider. The order is not important. It creates a brand new node, Bifröst Collider. I'm just going to rename it to Bifröst Collider Bottle. We need another collider, and that is our glass. So I'm going to select the liquid, select the glass. I'm going to go to Bifröst and create another collider. I'm going to change its name to collider underscore glass. Now, if I select my liquid and go to node editor, we can see all of a sudden we have more information. We have colliders. There are not too many attributes on the collider, but we are going to take a peek at that and have a look to see how it affects our simulation. Now, what I have done, actually, this is something that it's there by default. You can go and reset, enable background processing with enable scratch caching. You can actually have a look to see how the simulation works. So I have a very, very simple animation. You know, we pour wine into the glass. So we've already set the colliders and it should be good to go. But the problem is if I do a play blast, or if I just continue and go frame by frame, we can see although the surface collides rather beautifully, there is not going to be much of the liquid coming out. The reason is the voxel size. I'm going to go and select my liquid, and I'm going to go into my liquid shape and increase the point size to something like 4, simply because the points are really, really tiny. I have a difficult time seeing those. So let's go ahead actually and play blast this really quick and see what we're going to get. So if I play, the result is rather disappointing. The liquid doesn't come out. And as I said before, it is because of the amount of voxels. So the voxel size or the resolution is very, very important factor. And you need to make sure how to adjust it. I'm just going to go to frame 1. And again, it can be found in Bifröst Liquid properties. It's under resolution. So it's set to 5.5, and 0.5 is rather large. I'm just going to reduce this to 0.3, and immediately you see the liquid gets a lot denser. I'm just going to go ahead and hide the emitter, the geometry. Press H on the geometry because I don't want to see the geometry. And you need to be mindful of that. You should use a value that is small enough to give a good sense of the overall flow of the liquid, but still high enough for fast, low resolution previews, because reducing this value to a very low number will result in a very, very slow preview. Now, with that liquid selected, I'm going to go and create a kill plane as well. Now, kill planes are infinite planes. This means that you don't need to worry about its size. It's going to encompass the entire scene that removes particles which cross from one side to the other side. Because if I don't do that and you have excessive particles coming down, then they get constantly calculated and you surely don't want that. So that kill plane has been added. You can have more kill planes if you want, but one will suffice for me. What I can do, I will reduce or actually change its position to -0.5. I'm just going to bring it a little bit down in -y because I don't want this to intersect with the liquid I have on the table. Also, I'm going to select Bifröst Liquid, go to its attributes editor, and go to Bifröst Liquid Container, and I'm going to go to collision, I'm going to reduce that voxel scale collision to 0.75. Values between 0 and 1 results in finer voxels for collision. And this can be useful when you need more accuracy for your collision or acceleration, which we don't have, but you don't want to increase the overall resolution. So that's a really nice trick. So let's go and have another play blast and see what we're getting. Okay. Now if I look, you can see the fluid is not coming out or pouring out again. It does, but it's fairly slow. So that's one thing that I've noticed. It's like having an ocean rather than just a small scale liquid. Now it's really good time for me to talk about scene scale and its effect on the scene. See, Bifröst does not consider the value of working unit groups in your setting preferences. So if you set everything to cm, Bifröst is not going to see it. Instead, Bifröst see each visible grid unit as 1 meter. So it's clear as a day that this guy right here is probably 25 meters tall rather than 20 centimeter. And it doesn't matter how often or how accurate I change my scale in Maya through scale settings, you still get 1 meter per unit. So we need to go back and convert few factors inside our liquid to make sure that the way that Bifröst sees it is also accurate in scale. To address the scene scale, we have to address 3 primary factors. One is gravity, the next one is density, and the third important one is surface tension. Now, first, let's go and have a look at gravity. I'm going to go back to frame 1, going to go to Attribute Editor and select Bifröst Liquid Property Container. And that gives me access to gravity. Now, for gravity, I would like to reduce this, or rather increase this to a very high value. For now, I'm going to pick 600. What Autodesk suggests is to have that 9.8 and create 980, but I found 980 is a bit too much. So 600 for me to get things started is a good number. Now gravity is done. Let's have a look at our liquid density. Now liquid density is our Bifröst emitter props. If I go to emission, there I have my liquid density, which is physically accurate, but it's massive. I'm going to reduce this to 0.001. So that's done. Let's have a look at where we can find surface tension. Now for large scale scenes, we want this value to be off. Now I can go to Bifröst Liquid Properties, go all the way down into surface tension. When we have a small scale scene, then we definitely want to have that on, and the default value works just fine. Now we don't want to play back this just yet, because with that amount of gravity, if I were to play this, the liquid will pour out of the glass onto the kill plane and it's going to look horrible. So let's make some further tweaks before we get our third play blast, and only then we see how things are looking. First things first, just want to go to erosion and set my factor and factor near solid to 0. Erosion causes the surface to break up, and a small scene scale, this just doesn't work. The next one is I want to turn off my adaptivity, and that is on Bifröst Liquid Property Container. If I go and scroll up, this adaptivity causes a lot of problems. the way it causes problem is it defines more calculation at the center and creates finer voxel at the center and coarser voxel around the liquid. And again, it may be the case when you create a large scale scene, but for a small scene scale, we really don't need that extra level of calculation. So let's turn that off as well. While I'm on this panel, I can actually go ahead and reduce my voxel size to 0.25 to get finer voxels, and that increases the resolution, which is fantastic. Then I'm going to go to transport, and again, that's a very important rollout, and that defines numbers and times that calculations are performed for each frame. Of course, more iterations can result in much better accuracy. So for now, I'm going to set my step adaptivity to 0.9. I'm going to start with transport of 10. In my time step adaptivity, I'm going to increase this to 0.5, and maximum step, I'm going to set this to 5. I also need to address and create a little bit of dampening effect, and we don't have an attribute called damp, but we do have under viscosity scale factor. We don't want to make the liquid viscous. Of course, if you would like to create lava, honey, or oil, then you will put a really small amount of viscosity to make the liquid viscous. For wine, it's probably not necessary. For scale, I'm going to reduce this to something like 0.5 or 0.75. We'll see how we go. I may go back and change this attribute. Let's go ahead, and before I make further adjustments, have a play blast and see if things are looking, and then I may go back and tweak these attributes some more. So let's do a play blast and we'll be back. All right, let's have a look. Well, it's not too bad. At least we have a decent amount of wine pouring to the glass. So that part is good. The behavior is a bit erratic, and I think the resolution is a bit low, and we need to do something about the gravity as well. So some areas we need to work on. First things first, I'm just going to go and make further adjustment while I'm in this container. So I'm going to reduce or increase rather my initial gravity to something like 260. I'm going to reduce my voxels to 175, going back to the first frame. And then I'm going to put my transport step adaptivity to 0.95. Minimum transport step to 20. Time step adaptivity, I'm just going to increase this to 0.9. And min step set to 5. Max step set to 10. Also, I would like to keyframe this gravity. Around frame 65, I would like to keyframe it. Again to 260, but all in a sudden from this frame up to frame 200, I would like to reduce this significantly to probably 98. Now that should help us to have a better flow with much higher resolution. Also, there is something that I need to tweak, and that is again on my liquid properties. If I scroll all the way down, under emission droplet, I'm going to set my threshold droplet to 1. Basically, it says no droplet, and in particle distribution, I would like to set these to 3 and interior particle density also to 3. Now I guess it's time to do another round of Play Blast and see what we're getting. Alright, now we have a Play Blast for 90 frames where we tweaked the animation for the bottle a little bit and added a motion field, a little bit of drag to improve the flow. And look at the result. Instantly we see a huge improvement on the flow of the liquid. The fluid is not lightweighted like water anymore. It's got a little bit of mass to it, and it's very tamed thanks to the motion drag field. So a huge improvement overall. I'm actually very happy with the result. So let's go ahead and cache the fluid. Then we turn this to a mesh and export it as Alembic, and we're pretty much done. So to do that, I'm just going to go and select the liquid. First things first, I'm going to go to Bifröst option, and I make sure there is no background processing or cache management should be turned off as well. And now with the fluid Bifröst Liquid 1 selected, I'm going to go to Bifröst Liquids menu, and I'm going to go compute and cache the disk. Make sure to set projects so you can just save it into the right folder. And if you set project, then Maya finds the cache folder Bifröst and creates the folder for you. I'm just going to name this as liquid cache 01. Cache format is set to BIF, and we are going to use a compression format to simple because it's a very small scene. I'm going to go with the time slider, which is frame 1 to 175, and hit create. Now this will take a while, probably an hour, or you may experience even more simulation time, but we need to cache this out so there is no change to our simulation, and only then we're going to have a look at how to convert this Bifröst liquid into a polygon geometry. All right, we're almost there. Our cache to disk is done, and it's time to create a mesh polygon out of our Bifröst liquid. So with that Bifröst liquid selected, you go to liquid shape, Bifröst mesh, and just enable Bifröst mesh. Now I make a few changes to this setting. I can increase the resolution factor to 3, and that's the overall resolution. Smoothness set to 2 to add more smoothness to the geometry, and the rest is pretty much the default value. Now, final step is to go to cache, and with this Bifröst liquid mesh selected, you go to cache, Alembic cache, and go export selection to Alembic option box. Of course, we pick the time slider. The advanced option, we want to have UV right and right color set to be on, and that stores the velocity and the movement of our liquid, and we go export. I've already gone ahead and exported our liquid, and since it's Alembic, it stores it as ABC. So go ahead and store your liquid as Alembic, and just final note, your values shouldn't match mine. Obviously, unless you're using the exact same scene, your values will be different. The whole idea behind this tutorial is to learn the workflow and the process and how you extract the liquid. And now I'm going to create a brand new scene, import my bottle and the table and the glass with no Bifröst node, and then I'm going to go ahead and load my Alembic file through Alembic cache, import Alembic, and I'm going to bring my liquid.abc into a brand new scene, and we are going to continue with lighting and texturing. I've got the final scene right in front of me, and everything is ready but the liquid. So let's go ahead into cache, Alembic cache, and import Alembic. I'm going to bring my liquid. As you can see, the color set is there, but we need to texture it properly. So I'm going to select the liquid, go to Hypershade. I've already put together an AI standard surface shader, which is fairly straightforward. It's basically a shader with no base attribute, with specularity and index of refraction of 1.4, and also with transmission of 1 and a red color. I have this ready, so all I need to do is just to drag and drop into the model. Now everything is ready to go. I'm going to go to rendering, and I render the whole segment, and we're going to have a look at the final result in a second. Alright, I've gone ahead and rendered 100 frames. I still can get a much better quality by reducing the voxel size to something like 1.2, but I'm fairly happy with the result. I hope you've enjoyed this tutorial, and thank you very much for tuning in. See you in the next video.